So hello everyone. Today in this video we will discuss about a numerical problem related to arcs. Okay. So you can see here a figure of a arch is given here having the length and it is divided in different portion. You can see the total length of this arch is given 20 plus 30 plus 25 plus 25. Okay, and height of this arch from at the crown you can see here this one is 10 meter is given. So length is totally 100 meter. Okay, you can after getting this you can just get the value, and this one is 100 meter after adding this, and height of this crown is given 10, you can see. Okay, and two different load acts on this arch, you can see here. This one point load act at a distance 25 meter from the right side. Okay, this one 25 meter from the right side, this point load acts on this uh, arch. Okay, and you can see here, and this udl is also udl 30 kilometer per meter also act on this arch from C to D. You can see from center of crown to D point, and this UDL act in the distance of, you can see, 30 meter. Okay, so these values are given in the question, and now you can see in the question. Just read the question. A 2-inch arch, a 2-inch parabolic arch having the span is 100 meter and rise is 10 meter. Okay, rise is given 10 meter and span is given 100 meter. Okay, so this is given in the question. And temperature rises by the 20 degrees Celsius, and temperature is rises by 20 degrees Celsius, you can see here. Okay, and one of the upper yield by 6 mm, yield is also given 6 mm. And then we have to determine the moment, we have to calculate the moment, shear and thrust at D, neglect the deep shortening. Okay, we have to neglect the deep shortening, which I already told you. Basic formula for the calculation of horizontal thrust equals to H equal to integration my dx by ei. Okay, and it is divided by integration of y square dx by ei. Okay, so whenever yield is given, then we have to just add this, we have to just minus this delta in the numerator part. Okay, and whenever this value is given in the terms of kilonewton per meter or newton per meter like that, then we have to just add, instead is at the place of minus this delta, we have to just add in denominator part. Okay, you can say this k. So this is just only changes. Okay, and whenever the temperature is given in the question, then we have to add also L alpha delta in the numerator part. Okay, never forget this thing. And one also thing, if the deep shortening is given in the question, then we have to just add this L by AEA in the denominator part. This one is in denominator part, L upon EA. So don't remember this thing. So these are the basic concept. Okay, and if nothing is given in the question, then we have to just apply this formula, only this one, integration my dx by EA by y square dx by EY, only this much. Okay, we don't need to add other things like uh, k delta l by e and other things. Okay, so now let's move on the question. So we have I equal to ix equals to I naught sec theta, assume, and value of ei equals to 4 into 10 to the power 8 kilonewton meter square, and alpha equal to 1 into 10 to the power minus 5 per degree Celsius. So let us assume this thing. If these things are given in the question, then we can directly use the given value in the question. But if it is not provided in the question, then we have to assume. Okay, ei equal to 4 into 10 to the power 8 kilonewton meter square, alpha equals to 10 to the power minus 5 per degree Celsius, Okay, now next part. Now in very first we need to calculate horizontal thrust and the reactions. Okay, so let us suppose this H act. This is the horizontal support. This is also horizontal thrust. This H. Okay, and let us suppose this BA acts the reaction upward. Okay, so this is denoted by BA and this one BA. These two acts upward, this one also upward, and this horizontal thrust acts horizontally. Now we have to calculate the value of BA and BB in very first. So for this BA and BB, you can see here these two are the upward, so we just add BA plus BB. You can see here after adding these two BA plus BB, we get this value. This one is downward, so this is equals to 400 plus this 30. This ideally is 30 kilometer per meter, but this acts in a distance of 30 meter, on a distance of 30 meter, so we have to multiply this 30 into 30, so we get BA plus BB equals to 1300. This one is equation first. Now we have to take moment. Okay, now take moment about A. We have to take moment about A here. Okay, if you take moment about A, clockwise is negative, then you can see here, you can see this 30 into this 30 and 30 acts at a distance of 20 plus half of this 30. Okay, so it means 20 plus half of 30 means 15. So this acts at a distance of 20 plus 15 means 35. So the total load is 30 into 30. This is the load. Okay, and distance is 35. So this one is actually clockwise, so it is taken positive. And now you can see this one is 400. This 400 kilometer act at a distance of 20 plus 30 plus 25. Okay, so it means generally, if you add this all value 20, 30 and 25, its value is 75. So this is also clockwise, so it means 400 into 75. And now we can see this BB, this one BB acts this second clockwise, so this value is minus BB into total distance is from here to here is 100, so BB into 100. And after calculating this you will get b b equals to 615 kilometer. Okay, and if we put this value in the this given equation 1, then we get b equal to 685 kilometer. Okay, now it's turn to calculate L alpha del t. So now calculate L alpha del t. So as you know, L alpha del t equals to value of L equals to 100 meters, so we have to just put this value. Okay, and alpha is given 1 into 10 to the power minus 5, so we have to just put this value. And T is temperature changes by 20 degrees Celsius, so we have to just put, and this value becomes 0.02. And delta is also given 6 mm. Okay, yield value of yield is 6 mm, so you have to convert it into meter. 6 into 10 to the power minus 3, this is in meter. Okay, now